Hey there, my name is Molly Profit Sheets, and today we're going to be looking at 3 AWS services: Amazon Kinesis Streams, Amazon Kinesis Firehose, and Amazon RedShift. We're going to do this by creating 2 data analytics pipelines. The first pipeline is going to put data into S3, processed as Parquet. The second pipeline is going to take JSON records and copy them into RedShift. And finally, we're going to copy that Parquet data into RedShift directly.
As you can see on the right of the screen, we will be using the Boto3 library in order to authenticate with Amazon and then put records into those streams.
If you're coming from my previous demo on how to use Athena and QuickSight, we're going to be using the same PyDragons project, only this time we're going to be using the streaming files to stream data to Kinesis streams.
The first thing we need to do is to create 2 streams. I've already created one on the left here, and I will show you how to create the other. In Amazon Kinesis, you will want to click the Create Stream button. You want to give this stream name the same as the stream names in the spawn dragons to kinesis.py script. For this project, you only need 1 shard. Now that you've created this stream, make sure you also create the Dragon event stream. Now that we have our 2 streams set up, the first demo we want to prepare for is our Firehose Parquet demo, where we also transfer data to S3. In order to do this, we need to switch over to S3. You will need a bucket. I've reserved the bucket called PyDragons in order to use this project. Your bucket name needs to be globally unique. Within that bucket, my recommendation is to create a separate prefix or folder for the streaming demo. Then you want to create 3 prefixes or folders for failed, processed, and raw data. This is because you can back up your raw data to S3 as it is received by the stream. In your raw data, create 2 prefixes, one for dragon events and one for dragons. Inside dragons, this prefix also should go down to the hour. Next, what you're going to want to do is drag this dragon sample event into this folder. This is a JSON record that we will be converting to Parquet in our Firehose stream. In order to do that though, we'll need a glue crawler to read this sample event in order to establish the schema so that we can then use it in Kinesis. If you are unfamiliar with how to create a glue crawler, please refer to my Athena demo, which I'll link below. I'm going to go ahead and load glue to show you the tables that are formed from the glue crawler for this. So your table and schema should look like this. And if it's not, you may have to make some changes, such as the timestamp you may have to change. Once you have glue set up, we can move on to creating our delivery stream in Firehose. You'll want to click Create Delivery Stream. We're going to name this Dragon's Delivery Stream. We're going to choose our Kinesis data stream as our source. If you don't see it, hit the refresh button. We are not going to transform our records with Lambda, but we could if we wanted to, for example, add information to those records. We are, however, going to convert the record format, choosing Parquet. This is where our schema comes into play. We'll choose the region the schema was created in, choose the database, choose the table, and we're going to use the latest version. Because we chose the record format conversion, we can only deliver our destination to S3. However, we can back up our source records and also store our processed records. You'll want to choose the bucket that you've created. Then you want to add a prefix for where all these records will go. In the GitHub repository, I've included a requirements file. The first thing we want to do is set our destination file. If you go back to S3, you'll remember we created a process folder. Under Dragons, you'll see there's currently no data. So we need to tell Firehose where to put that data. You'll want to use the processed folder. You'll also need to specify where errors will go. You will remember that we also created a failed prefix. And finally, you will want to enable S3 backup in order to store your raw data. This points to the raw prefix. So that your data shows up quickly for the demo, I would decrease this buffer interval down to 60 seconds, which means you'll need to give it a minute when you start streaming data. Because your data is being converted to Parquet, you don't need to enable compression. You will need to create or choose an IAM role. You can keep the original policy document. This is going to give Firehose the access it needs in order to put your data into S3 and process it. Review everything and create the stream. Now you need to run the Python script in shell in order to see if the data will show up in your process folder in S3. To do this, you need to make sure you have Boto3 installed. You can run pip3 install Boto3 command to do this. Great. Now you need to run AWS Configure. You'll need an access key ID and a secret access key. You can create these in the IAM console when you create a new user. To protect my identity, I will be blurring this information. You'll need a default region name. In this case, mine is US East 1, as well as a default output. Once you've configured your AWS settings, you can run the Python script. If you see the data like this, it's properly sending. Give it a few minutes to show up in S3. Now that at least a minute has passed, we can refresh our processed folder to see if the data was correctly processed. You'll see that our prefixes were correctly added and we have a Parquet file. We can also check to see if our raw data was correctly backed up. You'll see another prefix was added that you didn't have before, and you'll see the streaming data was added as well. If you go to our other event though and check the processed folder under Dragon events, you'll see that there's nothing there. This is because even though we're sending Dragon action events and we have a second stream, we haven't actually created a second consumer in Firehose. By default, data can be retained in a stream for 24 hours, but that can be extended to as much as 7 days. However, we still want to do something with that data in that secondary stream. This is why we'll be building a second demo to showcase how to read data from a stream and copy it into RedShift. If you don't already have a RedShift cluster set up, the first thing we need to do is create a RedShift cluster. If you don't have it open, go ahead and open RedShift under Services and click Create Cluster. You can name your cluster under Cluster Identifier whatever you want, but we're going to keep it the default RedShift Cluster 1. We're going to select DC2 Large. We're going to use one node because we don't need a lot for this demo. We're going to go ahead and create a database called PyDragons. Keep in mind the database name and the port. You also need a username and password. I would suggest using a password generator. I'm going to go ahead and copy a password in. In the Firehose requirements.txt file, you can put this information so you have it for later as you set up this demo. You're also going to want to set up an IAM role for the cluster permissions. I've created a RedShift-PyDragons role, and all it does is have S3 access to the buckets where I am storing this data. If you don't have a default VPC, I would also recommend setting up a default VPC because we're going to use that later. And go ahead and create your cluster. Give it a few minutes to spin up the cluster. Now that your cluster is available, you're going to want to go ahead and click on it and go into properties because there's more information that we need. If you scroll all the way down, you'll see that we have a security group here. The default security group inbound rules are set up with all traffic. We don't want this. We actually need to make the cluster publicly accessible so that Firehose can access it. It also doesn't need an elastic IP address. Let that modify. Then my recommendation is to change this security group so that instead of it allowing all traffic on all types, you're going to want a security group that is more like this. It allows the TCP protocol, and specifically you want to allow your IP, which I've blurred, and Firehose access. So make sure you set that up. Once you've done that, you can change your security group to instead be your RedShift security group. Now we need to make sure we can actually access the cluster. In order to access your database, the final piece that you will need is the connection details for the host. We're going to use the JDBC URL, but we're not going to include this first bit. So just copy and paste after redshift : into the host name and post to go. Then you need the information you saved in your text document. So your master user, your password, and the database all go here, and hit connect. If this doesn't resolve, double check your security groups to make sure it allows access from your IP. Now we want to create a table for where our data will be stored and copied. Copy and paste from the document the following SQL query. And click Execute Statement. You should have a table that you can then see in Post2Co when you hit refresh called Dragon Events. This is where our data will go. Go ahead and open that. Now we need to set up the Firehose stream in order to send this data to S3 and finally into Redshift. In Firehose, go to Create Delivery Stream. We're going to call this Dragon Events Delivery Stream. You're going to reference the Kinesis stream for Dragon Events that we already created. We're not going to transform records or convert the record format. We're going to select Redshift. We're going to use that cluster we just made, and then you're going to need the same information you used before that you wrote down. And your table is going to be Dragon Events based on the table that you already have in Post2Co. You don't need the columns. This intermediate source bucket is where your source records will be stored. So you want to select the PyDragons bucket. And I've already included a prefix that you can copy in as well. I was going to put them in the processed prefix because we want them stored in gzip format. And the original source are JSON anyway. I've also included the information you're going to need for the copy command. You're going to want to add gzip format as JSON auto here. And then I would set that retry duration down to 60 seconds. Say next. Set your buffer interval to 60 seconds. Your buffer size can still be 5 if you want. We're going to pick gzip compression. We're not going to use encryption for this demo. You'll also need to create a new IAM role for this particular Firehose demo. Press next. Review everything, make sure it looks good. We're going to create the delivery stream. So once this has been created, two things are going to happen. One, in our S3 bucket under processed Dragon events, we should see some data be generated. We should also be able to see data posted here in our table in RedShift. So what we're going to need to do is go ahead and we'll clear this and run the script again. This time we're hoping that the Dragon events records will be posted to both S3 and then copied into RedShift. So we know that they're sending. Give it a few minutes and we'll check to see if it showed up in our two targets. I just hit refresh on Postigo and you can see that we have 1,000 rows were added to our Dragon events table. And if we refresh the S3 bucket, we also see that a folder for 2020 was added and that we have our delivery stream added here as well. And I'll go ahead and run it again so that we can see more rows get added. So every time we stream, we get more rows. And you can see after we've run it again that more rows are being added now. Now that your data is successfully copied into RedShift, you can create other tables, join tables, and really run some interesting queries on your data. What is interesting, if you wanted to explore more, you could copy the data for the Dragons table from S3 that was stored in Parquet into RedShift, as RedShift does allow you to copy Parquet. So as a bonus, I'm going to show you how to copy data into RedShift using the Parquet data that we created earlier. First, you're going to want to check your IAM role. Remember how I used a RedShift specific role that I had created? Well, I went back and added a trust relationship for RedShift. It looks like this. Basically, I'm giving access to the user here that is in the RedShift cluster, and that's the master user. The other thing that you're going to want to do is make sure to attach that IAM role to your RedShift cluster before executing these commands. So in the file here, I've created a query so that we can create a table in RedShift for this particular data. We're going to create that table. You can check it out, make sure it looks good. And then we need to update this table with data. So copy this part. And then you're going to want to replace bucket name with your bucket name for where your data is stored. It's PyDragons. And then you're going to want to copy that IAM role, the ARN for that role. And then once you have that, execute your statement. And it looks like the records were successfully copied. We're going to check them out, see what they look like. Might need to refresh it. Yep, so here they are. This is that Parquet data that we had done in the first Firehose demo, and it's now in RedShift as well.
Thank you for joining me to check out these AWS services. If you'd like to implement it yourself, go ahead and check out the links provided with the videos. And if you're interested in more content, please go ahead and subscribe.